Zip lines are fun and a little scary, but you're basically coasting down a hill. I want to feel like I'm riding a rocket, throttled by an external force. In this video, I try everything from rocket engines to lithium-powered motors and travel all the way to Boston to consult one of the smartest engineers on YouTube, all in a quest to make the most advanced zipline ride ever. To explain my problem with zip lines, we're using a free body diagram you'd learn in the first year of engineering school. If we orient the cable horizontally, the weight of the rider is directly opposed by an equal and opposite normal force. Since the sum of the forces is zero, the trolley goes nowhere, just like you'd expect. But if we put the world right again so the zip line has slope, the normal force stays normal to the cable. But the weight of the rider now has a part that points along the cable. Simple trig with a 10-degree slope says the force P pushing us down the cable is only 17% of our weight. This is essentially like coasting your bike down a hill versus pedaling. Look how much faster a bigger P can make us go. But zip lines don't have pedals, so I'm adding the thrust of rocket engines. I was surprised to learn the thrust profile of these engines is not at all linear, which had me doubting my calculations. So doing the math, this thing's going to have an acceleration a little higher than gravity for just under 2 seconds. That's going to take it to about the midpoint across the pond, and then we'll be going about 20 meters per second. So it should be crossing the rest of the pond in about a second and slam into the end. We'll see if the numbers actually add up. Let's see what happens. Of course, rocket engines are no joke, so to ensure I stay safe, I found someone's kid to light it for me. You may have noticed I sent the zip line uphill in the opposite direction it gets ridden. Part of that was to slow it down and avoid a crash at the end. But mostly it's because getting the trolley back up to the top is a pain, so what we really want is a zip line that accelerates a rider down, but can also run back up for the next ride. Now that we know return trips work on an empty trolley, let's use an even bigger rocket for the ride down.
Here goes. Was wild, but it could have been faster. Let's find out why.
The trolley by itself weighs just over 3 pounds or 1.5 kilograms, and the rocket engine averages just under 3 pounds or 12 newtons of thrust. So when running the trolley by itself, the math is quite simple. Rearrange F equals ma so that A equals F over m, giving us an acceleration of about 8 meters per second squared, which is almost the 9.8 meters per second squared we get from gravity. This is how I knew it was going to initially take off faster than gravity, as if I dropped it. But now let's consider the rocket pushing me at 180 pounds or 80 kilograms. Using the same equation with my mass shows the acceleration is less than 2% of gravity. Clearly, rocket engines are not going to work for speeding up a zip line. But for anyone that wants to run the experiment themselves, I designed mini Starship models to be 3D printed and use pressurized CO2 cartridges as the propellant. Try weighing yours down with different payloads and see how long it takes to get to Mars. Another way to move up and down a cable at high speeds is an electric motor, but I'm not sure how to keep one from crashing into the tree at each end. When I built my automatic knife throwing machine, I used LiDAR to precisely measure distance to the target, quite literally with laser precision. I like the idea of putting a LiDAR sensor on each side of the trolley to slow it down as we approach each end. While we're at it, let's add Wi-Fi and an IMU to detect if we hit an end stop on accident. We started by ordering an electric skateboard motor and controller and wiring them up to see if they'll spin.
We have movement.
Then I fixtured a drive wheel in a way my son could tinker with on his own. I've noticed when I give kids a taste of how fun this stuff can be, they're more likely to stick around for the less exciting steps.
Hey!
Kind of like a science teacher setting up a lab. Okay, this is kind of wild. A 3D printer company has just invited a bunch of us creators to come 3D print and prototype whatever we want. I was planning on CNC machining the rest of this trolley, but 3D printing would save a lot of time, and it better because this event is in a couple of weeks. So I basically need to finish the design now so that we can order parts, 3D print, prototype, and test in the 2.5 days that we're there. I'm excited. I'm terrified, and I'm wondering how smart it is to be suspending humans from a 3D print.
You want to get sued?
Predicting when a 3D print will fail involves breaking lots of samples on a machine called a tensile tester, much like this one I built in a previous video.
Whoa!
The graphs show us not only the breaking strength of a material, but how stretchy it was on the way there. I was so impressed with some of them, I printed a chain link and used it to lift my Bronco off the ground. If 3D prints can do that, supporting a human should be easy, right? But to know for sure, engineers develop software telling us the stress level anywhere in a part. It's called finite element analysis, or FEA. Here's an example where I used it to predict when 3D printed turbine blades would explode. But the engineers at the printer company pointed out I didn't shock load the link on my truck, nor did I cycle it more than once. So we compromised that as I designed the Zipline trolley, I'll aim for a 5 times factor of safety, or only loading it to 1/5 its braking strength. That's how we get see-through swimming pools in the sky. They look dangerous, but they've had all kinds of simulations and testing done to ensure they're safe. But in order to work with engineers at the printer company, I have to learn their CAD system, which is something I have mixed feelings about. As an engineer with like 13 patents, I've spent literally thousands of hours in CAD. So if I could find one that's even a little bit better, that could make my life a lot easier. Now that I've tried Onshape, I really like it, and I think a lot of you will too, which is why I asked them to sponsor this video. Honestly, the way they lump assemblies and parts into tabs is the cleanest I've seen. And if you need to explain your assembly, these 2 sliders are hard to beat. Plus it's cloud-based, so any conference room computer can run it. I even use my phone to check dimensions when I'm in the shop to avoid metal chips in my laptop. And I will not miss losing an hour of work because my computer just crashed. Onshape servers remember changes as you make them. But Quinn, I just want to model and 3D print stuff. I can't afford a whole CAD system. No worries. Onshape has a free version you can use to tinker all you want. But if you're an engineer, you and your coworkers can try Onshape Professional for free for 6 months while you figure out how much easier your life can be. Just look down in the video description for the link. So after mountains of CAD work and programming, Grant and I are on our way to Boston. Upon landing, we learned it rains so hard there, it even rains indoors.
That is inside of a store. That's how wet it is. Inside, it's that wet. I thought I'd seen everything.
We arrived to find engineers already hard at work building a zip line for us to test our trolley on. So Grant got to work upstairs on his Wi-Fi code with breadboarded electronics while we waited for our first 3D print to finish. Plus there were tons of other cool projects to check out. I've hung out with creators in a relaxed setting, but this hackathon was my first time engaging with them in the middle of their project. The engineers also offered to print our first part in their fastest resin, letting us do a quick fit check with the battery and holder. I scanned the battery pack back home and built a CAD model from the scan, which is never perfect, so I was relieved to see how well the parts came together. With only 2 days to work, there's just not a lot of time to reprint giant parts. Some of the engineers worked late into the night, finishing the zip line so it would be ready the next day for testing the trolley. The second and last full day brought us the few revised parts we needed for final assembly. We got all the pieces together, installed it on the zip line, and let's just say there were a few bugs to work out. You may have noticed we dropped my LiDAR sensor idea, letting the IMU detect the sudden stop at each end. But the IMU is so sensitive, it's picking up vibrations and stopping partway up the cable. No big deal, just bump the setting and try again.
Oh, yeah.
The next issue was entirely me. My tensioner didn't have enough stroke to grip this diameter cable. It was an easy redesign, but would take 2 hours to print, and we're out of time. So I went to work with a file and very improper use of a drill bit to get what we needed. But as I pounded the center bolt in, disaster struck.
Last pounding and putting this thing in, and I break the darn part. We're gonna use it anyway.
Then I noticed I hadn't filed the top surface enough and didn't want to head back to the shop for a file. So I used the next best thing.
What are you doing down there?
Hey, you gotta do what you gotta do.
Write your name.
Sandpaper, use asphalt.
Yeah, there you go.
That's not graffiti, it's a 3D print abrasion test. Though it suddenly looked like we were in the home stretch, the motor controller and IMU still took turns causing random stalls. But at some point, you just have to find a volunteer to ride the darn thing. Might as well be Shane. I hope I got those FEAs right.
Oh my God!
And yeah, we had a few more stalls, but that's what prototypes do. Eventually, the trolley started getting pretty repeatable. No, it's not very fast, yet, but it's got a brain and is going up and down like it's supposed to. Though we still have a ton of work to do, the hackathon was a huge success, setting us up to go crush it back home. And I mean crush, literally. Formlabs donated extra parts we plan to load until they break to test the FEA. Just watch the behind the scenes video on my Patreon page in the video description. The property owner with the pond isn't expecting us until the weekend, so we're setting up a temporary cable in the backyard that's easy to reach for troubleshooting. Then as Grant started to pick up the speed, it revealed new issues.
Oh, gosh.
So we added a homing step to measure the cable at slower speeds,
So now it's zeroed, basically?
Yeah.
allowing it to go fast most of the way without crashing.
Oh, wow. Good work. Oh, we're sapping our battery. Your look of annoyance only encourages me.
After one more late night of coding, we're finally back at the pond.
I see lights.
It'll go 3 times this fast next time, once it knows where it is.
It's gonna get its umbilical cord wet. Oh, if that catches a fish catching robot, I like it.
But the reality of a 10-foot drop is giving our guinea pig second thought.
How are you feeling?
I don't know. I don't know if this thing is even tight enough to keep me out of the water, but here we go.
Hey, is your phone in your pocket?
No, I took my
Okay,
phone out.
good.
Yeah, I might get wet.
Make sure you have a good grip.
Here we go. I survived. Okay, now, what am I supposed to do? Give this a push and it knows where it's at?
Yep. It should go
Okay.
3 times the speed that it did before.
Okay, here we go. Whoa!
As I said.
Yeah! That is what we wanted. Nice work. All right, I'm gonna go ride it again. It's friction in the motor, or not friction in the motor, but the fact that it's driving the motor a little bit, just additional resistance that there wouldn't normally be. I bet if I back the motor off where it's not riding, it would probably go faster. So we just gotta get Grant to program it to help drive us, to compensate for that, and overcompensate so it's more like a rocket.
But the trolley still kept wanting to stall a lot. Most times it was the IMU detecting a bounce, thinking it already hit the end stop. Sometimes a little too much vigor triggered an error.
And that's a current limit, I figured.
Oh,
Other times it stalled just because it wanted to.
How?
But we didn't give up, and long after sundown, it finally got better.
all right. So this will accelerate better, harder, faster, whatever.
Harder, better, faster, stronger.
Better, faster, stronger. Okay. That felt like free spinning, like there was nothing slowing me down. If anything, it was helping me a little bit. Whatever you did, I would increase it at least another third, maybe 50%. That was by far the best so far.
Yay.
Day 2 began with raising the cable a bit on each tree to make the landings a little easier. And any serious programming project has to involve runaway code at some point.
Oh, sure. Go, quick, pull the battery, pull the battery, pull the battery. I was trying to do I know.
But soon it got so reliable, I removed the retrieval cord, then instantly regretted it.
Hey, what happened to the line?
You took it off.
Ah, all right.
I think the other one up there too. I got it.
I took this string off and it stopped.
Why?
Because I wanted it to do this, I guess. Why did I take the string off?
Why would you wish this upon yourself?
But ultimately, we kept hitting a speed limit we just couldn't exceed.
Okay, so we have been trying to get this thing to work and it's not going fast enough. It's retracting up to the top just like it should. That's awesome. But we want this thing to accelerate and be faster than a regular Zipline. I thought it might be something in the programming, but I have my laptop connected to the O-Drive and it will not go above 42 revs per second. I can go 30 revs per second. It spins up. I can go 40. But as soon as I try to go like 50, it caps out at 42. 42 revs per second works out to 2,500 RPM. Because of our 3-to-1 reduction to the drive wheel, that means about 3 meters per second going down the line, and that's just not fast enough. I don't understand. This motor, by the numbers, should be capable of like 3,800 RPM. So it's either try to find different timing pulleys to speed the thing up, or just like, why won't this thing go faster? We're out of time here on this trip, so got to go back home and troubleshoot this stuff and hopefully have a successful trip next time. This not knowing why something isn't working, I should be used to it by now. I still don't like it.
I have to confess, I was in a hurry when I ordered the pulleys and just picked the cheapest and fastest option for skateboards without doing any math. Now that I checked the torque, our 7 Newton-meter motor with a 3-to-1 reduction can apply 150 pounds or 670 newtons at the cable. That explains why it so easily shredded the drive wheel when it went out of control against the stop. If I'm willing to wait a couple weeks, I can change to a 1.6-to-1 ratio, be almost twice as fast, and still have 80 pounds or 350 newtons on the cable. Plus, I found a forum referring to an artificial speed limit in the motor controller that can be overridden at user discretion if accuracy isn't paramount. So while we wait for the pulleys to arrive, we play a little more on our home Zipline and find one more spot the cable can rub.
Rub marks.
Which I see as a chance for Grant to get practice making more chips on the mill.
There we go.
He also got the Wi-Fi working well enough to remote control the trolley with his laptop, enabling him to fish with it if we have time.
A very simple web request.
Once the pulleys arrive, I opt to machine the larger hub down rather than redesign the motor holder. All we need now is another day at the pond. But since the pulley ratio is nearly half what it was, the torque and current settings are way off. And apparently, I forgot to tension the timing belt.
Oh, did you hear that?
Then, exactly as you'd expect, it stalls the first trip up the cable.
So did it...
But this time, the property owner put the boat away, so I get to take a nice cold dip instead.
Yup, it's cold.
Also, it finally dawns on me, the trolley can drive itself down the cable now, so I don't have to be a crash test dummy for every ride.
Oh gosh, that is scaring me. Like it's gonna wreck.
But I tell Grant I can't ride it without some sort of slowdown at the end, so he tells it to coast to a stop, but then has to make it finish on its own, which will help when a rider drops into the water partway down.
Hey, that's pretty good.
Eventually our guinea pig gets brave enough to try again, and I'm glad I did.
Oh yeah. Is it gonna get me to the top? Okay. I felt that. That accelerated. That was cool.
But though the code is changing between each run, the speed of the motor isn't. Grant still hasn't lifted the RPM limit I found, fearing it could affect accuracy. But while the ride is fun, it still feels like it's made for kids at a carnival. Grant even gives it a try, and all we get is a look of wonderment that it actually works. So I tell him, look, we'll deal with the accuracy later, just lift the speed limit and let's do this. In retrospect, I probably should have sent it down empty the first time. Let's have another look at the emotions on my face at the end.
I think that was the limit. I almost ditched. I almost jumped off. I was like, is this gonna kill me? Woo! What's my heart rate? We gotta change something. That was not good.
Even with more speed reduction at the end, it still leaves the old Zipline behind. You can tell when you ride it, the old one feels kind of boring now.
Yeah, that just feels lame compared to...
One challenge I haven't mentioned is whether the trolley can survive someone letting go. The force in the cable is the same before and after, but suddenly losing my 180 pounds sends the 3-pound trolley skyward at over 50 Gs. Fortunately, the new trolley weighs 15 pounds, so it should only experience 13 Gs. But that's over and over as it bounces around. I'm just hoping nothing flies off and lands on my head.
Oh my gosh, look at that thing.
Miraculously, the trolley survived, so we got permission for Grant to fish using his Wi-Fi code and laptop. Become a patron of Quint Builds to see what happens.
Oh, Grant, reel him in.
Lastly, I have Grant remote drive me out over the pond so I can fish with a pole.
It's starting to struggle. Go ahead and pause it.
Uh-oh. The plan was that I was going to come out here and fish, but now it seems like driving me up that zip line was enough to overwhelm the little set screws that were holding this drive pulley. So now I need to figure out how to get off of this thing. I could just drop into the water. I do have some electronics on me. I think I'm going to try to Mission Impossible this thing back up. I'll show you that after I give you the outro. Hope you enjoyed this video. I've made some serious life changes to be able to put a lot more time into YouTube, so you can expect to see a lot more videos from Quint Builds from now on. Please like, subscribe, and that way I'll see you in the next video. Okay, let's see if we can, oh yeah! Dun, 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 dun.